Alright, this is chapter 3.2, problem 3. It says graph the function, state the maximum or minimum, the domain or range, and where is it increasing and decreasing. Okay, so we have kind of a laundry list to do here. So first things first, let's get this graph up there. So your vertex is at, we're doing a standard form, so we need the whole negative b over 2a, okay, which in this case, negative b over 2a, so that's negative b, so that's negative 2 over 2a, so that's 2 times 1/2. Well, that's 2 divided by 1, which is 2. So the vertex is at 2, comma, and then plug in 2. 2 times 2 is 4. Divided by 2 is 2. Negative 2 times 2 is negative 4. Minus 1. 2 minus 4 is negative 2. Minus 1 is negative 3. Erase all that. So that's at negative 3. We just plugged in my negative b over 2 squared. Negative b over 2a. Got that. So last but not least, your axis of symmetry is at x equals 2. So let's go ahead and graph my vertex at 2, negative 3. 1, 2, negative 3. I've been using green, so I'm going to stick with that. Negative 2, negative 3. Okay? And let's keep going. 2, negative 3. So let's work our way up to 0, 1, 0. That might be enough. Oh, again, we're dividing by 2. So I want to pick things that'll divide easily by 2. So let's do 0 and then negative 2. See what that gets us. So 0 is nice because 0 and 0, that's just a negative 1. So 0 is negative 1, 4 is negative 1. Negative 2 is a little different. Negative 2 squared is positive 4. Divided by 2 is 2. Negative 2 times negative 2 is positive 4. Negative, and then minus 1, 4, 6. Minus 1 is 5. Negative 2, 4, 5, 6. Will be 5. So let's try one more. Negative 4. See what that gets us. Negative 4 squared is positive 16. Divided by 2 is 8. Negative 2 times negative 4 is positive 8. So that's also 8. Minus 1. Okay, that's 15. So that's off the graph. So that's good. We don't have to worry about negative 4. So we've got 0, negative 1, and 4, negative 1, and negative 2, 1, 2, 3, 4, 5. So positive 6, 5. So here's our graph. So it opens upwards, so we know it's going to have a minimum. So the minimum, once we get a graph, we can just pull pretty much everything straight from the graph. Your minimum is the lowest point on the graph. So minimum is at the minimum is at y equals negative 3. Because that's right there. That is the lowest point on the graph, where y is negative 3. Okay. They want the domain and range. Well, the domain is all real numbers because it goes left forever and right forever. The range is from your minimum up. So your range, now I don't care if you use this form where minimum is negative 3 to infinity, or if you use inequality form, y is greater than or equal to negative 3. Because all of these, my range is y, so all of these points are bigger or equal to 3. Okay? Let me erase that. Last but not least, where is it increasing or decreasing? So I'll start with increasing and decreasing. Alright? Increasing, well, where does it have a positive slope? Increasing is on this side. This is my increasing side. This is my decreasing side. Because that's where it's going down. Alright? So everything to the right of the vertex is increasing. So everything, all your x values to the right of that. Alright? So all your x values to the right of your vertex. So when x is greater than 2. It's decreasing everything to the left of the vertex. So when x is less than 2, the graph is decreasing. Alright? Now you don't need to write all those red and orange lines on the graph, but they're just there to kind of help prove the point. So I'll erase those. This is what you should have on the graph when you're done. Erase all this. There we go. But that's what they're looking for. They wanted the graph, and they wanted this information. Okay? Try B and C.